I remember the things that we have prepared for, and oh yeah, so we'll be able to help each other out however we may need to, and we say this in the name of Jesus Christ, amen.
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 Okay. How did studying go for everybody?
It's good.
Yeah, it wasn't good, but it wasn't as bad. We'll
I
see.
totally got lost at the end. Yep. See how we did. Do we have any questions from the reading before we do the quiz?
Yeah, I don't know. Like you said, I kind of got lost near the end with those tables. Really confusing. I don't know if we'll have that on the quiz or not, but
Yeah.
Was it the ones about the Powerball?
yeah, Powerball.
Yeah, finding the standard deviation and what else was it? The mean of a discrete random variable, and then finding the standard deviation. So, but I guess we'll just see.
Yeah.
Because the mean is the average number, right?
Right.
Like, okay, and then the standard deviation is just how far away from
the mean
that number the rest of the numbers are.
Yeah, that's what it sounded like to me.
Cool. It's just getting those numbers didn't make sense to me. Okay. Should we go ahead and start the quiz?
Yeah, that's fine.
Yeah.
Is that your baby?
Yeah, this is my baby. Say hey. Just chilling it. Does everybody have the quiz?
Yeah, I've got a little bit.
Okay. I guess I'll just take the third question. Human blood can be classified into one of four basic types: A, O, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. 45% have O, 40% have A, 11% have B, and 4% have AB. The blood types and the proportions given in the table above define a probability distribution. Is that just asking if it answers or follows the three rules that the rules were probability has to be between 0 and 1. The sum of all the probabilities has to equal 1, and the probability of it not occurring is 1 minus the probability. So I think it follows all the rules, which would mean true.
Okay.
Guess who it is? Hello? Hi. It's ringing.
On again. Are you guys on?
Yeah. Yeah. Did you check the box that said you agreed to the conditions, or did you even get? Did it?
No, I didn't even show up that yet. Because that's where it's just like, well, why did that box show up this time? You know, and it didn't show up last time. This time it did. And so I just keep trying it. It won't let me check it at all. So anyway, I just didn't want to. I want you guys to, go ahead. But if you just put me on speakerphone again till I figure this out, do you mind?
Oh no, that's great. Ross, do you have any suggestions for her or Mike for how to log in?
I don't.
No, she said she saw the checkbox and the join button, right? It just won't let her.
No, I can't even get the join button right now. Now, I'm on Google Chrome, and I copied and pasted, and then I also tried just clicking on the mail and just let it go right to it. But it goes to my old one, so.
Have you tried signing out of your old account and signing into the one that you want to use?
I don't. Okay. You close them down. Well, I can get in. I can do the quiz and stuff if you guys want to just start. That's all right. I'll keep working at this. I'm sorry. I apologize.
No, you're fine. We're on the first question. So we were just talking about how the probability follows all three rules. So I would say that it is true. Does everyone agree?
Yeah.
Yeah.
Yes.
Okay. Who's up next?
Okay, I'm clicking into the quiz right now. So.
I'll take number 4. What is the probability that a randomly selected person in the United States has type O blood? The probability. So that would be 0.45, right?
I think so.
Sounds good to me.
Okay, I'm there now. Let me just go with you. Okay. Yeah. True. Okay. So we're on question 3 or 4?
Well, on 4 it says round 2 decimal places. I don't know if that makes a difference.
Yeah, I think it's already at 2 decimal places, so we won't have to worry about it this time.
Okay.
Yeah.
So we got true for number 3 and 0.45 for number 4.
Point. Okay, so number 5. I can read it. What is the probability that a randomly selected person will not have type O blood? And that is up on the top. So not have type O. It would be 4, 5. 5.5, right? 5.5?
I think it'd be 0.55.
Yeah, 5.5. 0.55?
Yeah. Yeah, that's what I got.
Yeah, I agree.
Okay.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. And if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen in the bladder cancer patient? I'm thinking maybe 1 out of 7.
That's what I think.
We need to turn it into a
Limit
decimal.
decimal,
And for 3 decimals, that'd be 0.143.
That's what I got too.
Awesome.
Is that 1/7? Is 0.143? I don't know. Get that up.
Yes. 1.
Okay. I'm going to put this in. Yeah, okay. I got that. Okay.
In a combination total of 54 trials, the dogs correctly identified the specimen for the cancer patient 22 times. It is very unlikely that a dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there is little evidence that dogs can detect bladder cancer. So the dogs are right roughly a little bit less than 50% of the time, which is a lot more than 14% of the time. So I would say that's strong evidence that they can detect bladder cancer.
I think so.
I would agree with that.
Nice.
You said they can?
Oh,
Can, yes, they can.
so is it my turn? I'm not sure where I'm in the lineup here.
Sure.
It's my turn.
Oh, Ross's turn.
Okay.
Use the following information to answer the next 3 questions. M&Ms are small chocolate candies. The M&M website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. Brown 13%, yellow 14%, red 13%, blue 24%, orange 20%, and green. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? So that'd be 0.13.
Looks good to me.
Yep. Me too. 1, 3. Okay. And then question 9 is, what is the probability that a randomly selected candy is green? Wow, I get the one without it. Okay, let me add them up. Hold on. 3. Whoa, I get higher than that. I didn't add something right. Still working on this one. So, okay, let me clear my thing again and add them.
I always hate it when I'm in a rush and I always mess up.
Yeah, this is like, here I'm like, you guys aren't waiting on me.
No, we're not waiting. We're all doing it too, so no big deal.
Okay. 0.2. So it'd be 0.16. What'd I get?
That's what I got.
What you guys
That's
get?
what I got.
I
That's
got
what I got.
2.
Okay. This is like an easier
All right.
week. I hope most weeks are like this.
Yeah.
All right. So question 10, what is the probability that a randomly selected candy is not green? I have 0.84.
That's
Me
what I
too.
got.
What was that?
0.84 is the
Oh, it'd be the opposite. Yes,
The
I get that.
opposite.
Okay.
Okay, the ACT scores of students admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. The mean was 24.3 and the standard deviation was 4.3. And a lot of other numbers. So half of the observations are less than or equal to what number, and the median is 24. So would it be 24? Yeah.
I think so. Yeah.
24.
Yeah.
Yep.
Because the median is different from the mean.
Median is like the
median.
middle number.
Yeah.
Yeah.
Okay, cool.
All right. Question 12. Based on the information on the table above, the top 25% of the students scored above what number? Above 27?
I think so.
Yep.
Okay. 27. Okay. Number 13. My lucky number. I love 13. Okay. Which of the following statements is not one of the three rules of probability? And I wish I would have wrote them right in front of me. Probability that an outcome will not occur is 1 minus the probability that, well, what is not 1? Okay. That is 1. I think it's the third one. If the probability is high, then the probability is positive.
Yep.
Would you agree that that's not one of the rules?
I agree.
I agree.
Yeah.
Okay. Oh, Stick?
Is that the last one?
Yep, that's it.
It is.
Does someone want to submit it? Make sure we did.
Oh yeah, I already did it. Yep, it was all good. I just did it.
Yeah, Mike's on top of it.
Awesome.
Right.
Well, that was a nice, easy one.
Not bad at all.
Did anyone do the homework yet?
Not yet.
You guys are
I did the homework.
so you do the homework assignment, but we don't turn it in. We just do the homework quiz. Is that right?
Yeah.
Right. Yeah, that's how I run it.
Oh, fun. Okay. Cool.
Yeah, I've done the homework, so I just haven't done the quiz. And I think I was going to ask nothing. Lily, is this a problem for you if I just call if I'm getting in trouble with this?
Not at all. I think last Thursday it was a little bit of a problem just because I was in the car. But I don't ever plan on doing that again. So.
Okay. All right. Well, hopefully I'll figure it out. I thought I had figured it out again, and because I made Google Chrome my I thought it's going to work this time, and it's not. It's just sitting there doing nothing. So now I'll try to figure out the next thing.
I wish I could.
Thank you for your understanding.
I wish I could look at your computer and see what was going on. But we'll figure it out. This will work.
Yes, as long as this will work for you, and I'll email then Sister Lemon and let her know that sometimes I still have issues.
Okay.
I don't think she'll have a problem, but she'll let me know if she does.
Right.
Okay.
All right.
Thank you.
Thank you. I think that's it for today.
All right.
All right.
Have a good
Thank
one.
you.
Wednesday.